energy storage manager at Solagent. I'm very excited to kick things off and introduce Jeremy Niles. He is the marketing manager for the clean energy sector of GENERAC. And we're going to be talking about load management. I'm particularly interested in this topic because batteries have been around in the residential market for some time now, but getting really dialed in on managing your loads and understanding how and when to use your battery is kind of the next frontier and the next really important thing that we need to be doing with the way that our storage is working. So GENERAC is doing a really great job of, creating a product line that supports this feature. So we are going to hear Jeremy give us all the details. So without further ado.
Right on. Thank you so much, Madeline, and welcome everyone to today's presentation. As you already know, this webinar is about load management. What we're going to be focusing on is understanding it, what it is, and how to use it to your advantage to design higher performance solar and storage installations, and of course, how to make that work for you, how to sell systems better that meet your customers' needs with a higher value product. So let's dive in. Kind of just outlining what we're talking about here today. Load management, I think, is probably going to be as revolutionary and impactful to solar and storage as storage was to solar. We're going to get into this more, and we're going to show you a bit about how load management lets you install less equipment to cover more loads. And if you can imagine that, doing more work with less equipment, the benefit is pretty obvious when you are in a competitive market. If you have load management as a trick up your sleeve, you can sell a higher performance system for less money and be able to win more bids in your marketplace. It's also going to provide a handy workaround for some sticky code issues. If, for instance, your AHJ enforces Article 702, you're going to have a way that you can meet that code without having to oversell storage or be quite so prescriptive with the way that you allocate or size loads to a protected loads panel. For your information, this is who I am. My name is Jeremy Niles, and I'm the channel marketing manager for GENERAC's Clean Energy Solutions Group. Basically what that means is I'm completely dedicated to supporting you, our dealers, our installers, and distributors with programming, education, and promotions that are going to help you sell. I've been in solar and storage for 7 years now, and I came to GENERAC with Hvac Energy at the time that we were acquired by GENERAC. It's been a pretty awesome ride so far. Later on, he's not up here, but I'm going to be joined by Sam Eckel, and he is one of our sales applications engineers, and he's going to help me field any of the more technical questions that you all throw at me. Great reminder, there is a question and answer feature in Zoom's webinar platform here. I do encourage you, at any point you have a question, please type it in to the Q&A box, and we'll get to that at the end of the program. Sam, getting back to Sam here, he's a key contributor to our manuals, our installation diagrams, and any of the other technical resources that you'll find at generac.com. He travels an awful lot supporting installations all across the country, even during COVID time. So we're really lucky to have him here today. And because his time is much more valuable than mine, I'm actually not putting his contact information up here. I don't want to. I'll take the spam. Leave Sam out of it. Okay, so here's our agenda for the hour. We're going to have a quick look at GENERAC as a company, take a look at our history in the energy technology space. And then after that, we're going to get into a quick orientation on the PWRcell system. If any of you are unfamiliar with PWRcell, this is going to be just a brief orientation to our product line. And then we'll get into discussion. What is the problem that load management solves? And then, of course, how do we solve it? How do we do that with load management? And then we're going to show you a couple good examples about how to actually implement these solutions for yourself, both as a designer and as a salesperson, so you can win more contracts and make more sales using PWRcell. So let's dive in here. If there's one thing that you should know at GENERAC, it's that we invented home backup power. Since 1959, we've been making generators that keep people's lights on. And in 1989, we brought another massive technical innovation to market. And that was the automatic home standby generator. Since then, we've been imitated, by a lot of the biggest brands on earth, but we have never been duplicated. And we've grown into a company, taking in over $2 billion in revenue per year, market cap in the 30 billions, I believe now. We just entered the Fortune 500 list, and we have an installed base of over 2 million units in North America, which is amazingly pretty close to the number of residential solar installations that we have here in the United States. Now we're innovating again. We're not satisfied just being, a large, old, stable American manufacturing company. We're taking it to the next level, and that's what we're doing here with whole home solar and storage, and that's what PWRcell is. This is our first entrant to this exciting market. So, of course, we did not invent this category. We didn't invent solar or batteries, but I do think that we're going to perfect it, and I do think that our load management scheme is going to be part of what really sets us ahead and apart from the rest of the field. So let's check it out. This is the PWRcell system, and just a brief overview of each component. Right here, we have the PWRcell battery. This is our energy storage solution. It's indoor, outdoor capable, and it's incredibly easy to install thanks to its modular architecture. This is sort of like an enclosure, and inside of it, you can put anywhere between 3 and 6, wow, that's not much of a square, 3 and 6 battery modules. Nothing in this system weighs more than 75 pounds, so it's incredibly easy for just 1 or 2 people on a crew to install. It's very high capacity, and it's larger configurations when you add more modules, and it's extremely powerful as well. One other really neat thing is that it DC couples to the PWRcell inverter here, which let's take a look at that. So super efficient connection between the solar that you're going to have up here on the roof, right, and the battery and the inverter. The PWRcell inverter here, unlike other systems, unlike other systems, right, they're going to have a battery inverter or have an inverter built into their battery, like some of the sort of bolt-on AC couple batteries out there. This is the only inverter in the system. The PWRcell inverter is the only inverter you need in a PWRcell system. It controls both the solar array and the battery storage, and DC couples to both of them. So it's extremely efficient, and because everything is talking using the same DC bus format, it's a totally plug and play install. There's no messing around with communication cables or wireless communication formats, whatever. It's a really simple installation. Importantly, this is a transformerless grid forming inverter, which means that when the grid goes down and it's time to start powering loads on the AC side, in less than 1 second, it's creating its own 240 volt, 60 hertz grid to keep your client's home powered. Pretty fantastic. Doing this without any intermediary or help from an external auto transformer. Last but not least here, we have the PWRcell transfer switch, okay? And this is a specialized transfer switch that is based on, the ones you might be familiar with. If you're familiar with GENERAC, we sell these for our generators, but this one is optimized to work with the PWRcell system. In a whole home backup system where the inverter diverts backup power to all the loads in the home, that's what we're talking about here, right, is whole home power. This switch cuts off the grid and keeps all of that power on premises. Additionally, it has some load management features built right in that allow it to control HVAC loads via their connected thermostats. So again, purpose-built ATS, has some load management capabilities built right in. PowerZone is our rooftop solar solution. This is different than a lot of the MLPE or module level power electronic solutions that you're familiar with, largely because it uses a lot less or many fewer complex components on the roof. Installation is faster as a result, and it's more robust. It has far fewer points of failure. Despite having fewer electronics on the roof, PowerZone still yields excellent shade performance and better performance actually in full sun than module level power electronic systems, right? They have to feed all of those little computers and power electronic converters. With PowerZone, a single string can carry up to 7.5 kilowatts. So for a lot of installations, you're going to get to do a lot less wiring, save time, save money when you use PowerZone with PWRcell. That's PWRcell in a nutshell. Essentially, because GENERAC owns each component, up on the roof, We own the inverter, the battery, and now, the user app experience and all of these fantastic AC side load management solutions that we're, covering today here. I think we can pretty safely say that we have the best integrated solution on the market. And the results speak for themselves. Not only is it well integrated, but that integration kind of reveals itself in this way. We have much higher power, much higher capacity, and much greater motor starting capacity than any of our competitors. So I think that you don't have to focus on the soft benefits. You can really see that those soft benefits pay dividends in the form of higher performance on this side of things. So speaking of high performance, we have a really high performance system. It's clean, simple to install, powerful, lots of capacity, very well integrated, cutting edge, winning the spec war, etc. But there is this problem that is always persistent, and that's that even when you have the most available, people always want more. And if you want to give them more the way that you always have, it's pretty expensive to do so. And let's see what I'm talking about here. What I'm talking about is that current systems are performance limited. To get more power or more capacity from a system, say a battery system, you have to increase the size of that system, right? If you want to cover more loads with a battery, then you need to get more power or more capacity from that battery, which means that usually you have to add another battery or several. And that's a really expensive way to add performance. And I might argue that because power and capacity are proportional to the dollars that you're spending on that system, you're not really increasing performance at all, right? We know how to optimize. We know how to increase the performance of every other technology that we use. Car engines, are smaller and produce more horsepower using less fuel than they did in the past. Computer processors, solar panels, cell phones, all these things doing the same, following the same kind of trend, right? No one's adding 2 engines to their car because they want more power. So why do we do this with batteries? What if we could break free of that 1-for-1 relationship, right? Dollar for dollar, kilowatt for kilowatt, how do we add performance rather than just adding batteries to a system? And today's webinar is going to cover, again, some GENERAC exclusive technology and design strategies that you can integrate today to design higher performance systems that provide better value than anything else on the market. So before we go there, let's look at where we have been. Let's look at what's currently going on in the market. What solutions dominate and why? What is the status quo for solar and storage integration? And if you've done this before, you know that it's the sub panel, right? This is what we've all been doing for a long time. This here is the main panel. And in order to back up loads in the home, we have installed a sub panel. We've moved the most important loads in the home to this little guy over here with a pretty hard limit, in this case, 33 amps has been typical. And these are attractive. They worked out well because it kind of deburdens the installer. You get to set a hard limit. You don't have to try to sell enough storage to cover everything at home. You don't have to try to design a custom integration of any kind. You down select to the essential loads. You place them in a separate panel and just install enough battery to cover those. And that's been it. And that's been okay, but it's not exactly high performance, right? It gets the job done, but only having access to the essentials during an outage is really not enough for everyone, right? We're getting out of the phase, right, where solar and storage is just for early adopters, solar enthusiasts, that kind of thing, and getting to the point where GENERAC's omni-channel marketing, we've got infomercials running across Middle America, during prime time. So new people are getting exposed to this technology, seeing its benefits, buying it, and more and more people have higher expectations. So, in a sub panel installation, what if there's a multi-day outage and your customer encounters a scenario that you did not plan for? You probably, as a professional, do a lot of pre-planning, working through different scenarios, trying to determine what goes in that sub panel. It would be understandable for you not to put the laundry circuits, right, or the air conditioning, or the garage doors, or maybe even forget the security system, in that essential panel. But after a week of power outage, someone might, want to do a load of wash, right? Furthermore, if code permits you to put more loads in the subpanel than the battery can serve simultaneously, right? A major risk without load management is that you're going to brown or black out the battery with no recourse during that outage. Many batteries don't actually have the ability to recover under their own steam, under solar power. The only thing that can bring them back up is the grid. And the only thing worse than a power outage, right, is being in a power outage with an out of commission backup system. A very disappointing situation to be in. So for PWRcell, because we are bigger and have more capacity and more power, running just the essentials looks, pretty good. It's not bad. And you might actually be able to keep on some of the larger essentials, right? Your well pump, that kind of thing could reasonably be on the protected loads panel. But what about all that other stuff in your customer's home, right? How do you tell them that they can't do the laundry or open the garage doors or use the entertainment room during an outage? Tough stuff. For people who can afford it, one answer has been to just buy more additional capacity, right? And this works, but it's a major investment. And it's just to meet a temporary spike in demand, right? That extra capacity is going to be sitting around unused probably more than 99% of the time. It would be kind of a big waste. And not to mention, you need a lot of room to install a system like this. So what is the higher performance solution? Spoiler alert, it's going to be load management. The world continues to be an unpredictable place. People are spending more time than ever at home. And more people, again, because of, just the way the market's going and the efforts in part because of the efforts of GENERAC's marketing here, are taking a serious look at solar and storage as a solution to not only backup power, but to cost savings as well. And to meet the needs of every homeowner, we have to go beyond the subpanel. We have to go beyond overbuilt. We need to produce higher performance systems. So let's start with a metaphor. We're getting, about halfway through April here, and just about 1 year ago, more than a year ago, the entire world was getting engaged in what is the biggest discussion about load management ever, I think. And of course, at that time, we were not talking about solar and storage, at least not on that large scale, right? We were talking about how to make the most of our limited resources in response to coronavirus. And what we came up with as a plan was that instead of using a lot of resources to build more hospitals than we generally need, we enacted load management strategies that allowed us to keep our existing hospitals running at or below capacity, right, without exceeding capacity. We call that flattening the curve. The idea behind load management for solar and storage is similar, although obviously a lot simpler, and the stakes are obviously much, much lower. Basically, load management allows a solar and storage system to run at capacity while safeguarding against system failure, rather than overbuy or overbuild a system, add a lot of capacity that will sit around, when there's not a spike in demand occurring. We can use load management to intelligently control and sequence the way that loads turn on. When we manage loads, we ensure there's always enough capacity for the highest priority loads. And we can see on the graph here, the difference between a system that involves load management and one that does not, right? In red, you have this big old spike in demand, right? But that exceeds capacity. And that, in the case of an electronic system, a backup power system would probably knock out the system and you wouldn't get anything out of it after this point. In blue, we can see that we have load management, right, with protection here. When we run at or under capacity, everything, we get to serve all the needs here, and runtime is actually extended. So load management actually enables a higher performance system here. By preventing all the loads from turning on at once, we ensure access to power for all loads just over time, right, over the course of the outage event. The result is a system with the same capacity, the same cost, but much higher performance. So now that we know some about why load management is important, let's talk about what it is. And broadly speaking, load management technologies prevent the circuits from drawing more than the backup power system can serve. Even though some loads will be prevented from running simultaneously, A good load management system will not prevent any loads from being run during the course of the outage, okay? Unless, of course, that load really has no business being on an outage. You know, hot tubs, pools, that kind of thing might want to be prevented from running completely. But existing load management solutions are generally not perfect and fall into a couple of broad categories. Let's explore those here. So smart panels are one type of load management system that you may have heard about. Basically, these are internet connected distribution panels that replace an existing panel. They're very sleek, but they're also pretty complex, and they're also super expensive, not only as hardware, but when you consider the amount of electrician labor that takes to retrofit all the home circuits to this new panel, it can really add up. I saw a Wired article recently about a span panel installation that took 9 hours, and I believe that was, it was a retrofit, but still 9 hours. That's a lot of time to pay an electrician for. Another popular but low-tech form of load management is called load shedding. And load shedding is usually achieved using low voltage relays. This is kind of a more DIY, approach to load management. Basically what happens is when the grid goes down, relays open and loads are shed. That's it. They don't turn back on until the grid comes back. This is a little bit better than a sub panel, but it's not much better. You don't have a separate panel, but you're not getting those loads at any time during the outage. And there's no intelligence, controlling how they go off. Just the binary, is the grid on or is the grid off? GENERAC has a third option available. It's cheaper and easier than a smart panel, and it's much smarter than load shedding. So let's check it out. Here are some of the components that we use in our load management system. We're not going to take a terribly deep dive on any of them, but I do want you to be familiar with each component just generally. The PWRcell ATS is what islands the system in a whole home configuration. This is what we saw earlier. Basically, it breaks the connection to the network when the grid goes down so that all of the solar and battery energy stays on premises. Smart management modules do most of the actual load management. They install in line to existing home wiring. You can install up to 8 of them. When the inverter is having a hard time meeting the demand of transferred loads, it sends a signal to the SMMs, which drop the loads in reverse order of priority, so that the most essential loads are never interrupted. Lastly, we have the Surestart HVAC accessory right here. Basically, you connect this to an HVAC unit, and it drastically reduces the locked rotor amps or surge or startup surge on AC units, meaning that starting a 3-ton AC, even when there is base load in the home, is no trouble for even a single PWRcell battery. So these are some of the components of a higher performance load management system. Nobody believes me when I say how easy SMMs are to install. So I want to give a couple examples right here. Basically, they install in line with the home's existing wiring. They can go next to the panel if you have room, or they can just install, like as you see here on the right, to existing conduit or to existing, home circuits in some other part of the home, either near the panel or far away. They're incredibly flexible because SMMs don't require a control wire of any kind. They receive all their signals from the inverter over the home's existing wiring. So installation is really very simple. So here's some of those components, again, just laid out. When the grid goes down, the automatic transfer switch, or ATS, is going to island away from the grid, keeping all the battery and solar power on premises. That's what you're seeing here. No more connection to the grid. The essential loads, you can see that these are green. These should never, these are the essential loads. These should never lose power, okay? And non-essential loads, what they're going to do is basically share the balance of the power that's left over. So how that works, they basically take turns depending on how much power is available. Smart management modules basically control these managed loads, pausing them to yield power to higher priority loads. So you can see that the hot water heater wants to start. The AC unit is going to turn off, and the hot water, if it has a higher priority, can turn on. So let's check this out in a different way. Another visual example showing you the difference in function between a sub-panel setup and a load managed whole home setup. On the right, we've got 9 kilowatts of loads that can be protected with our load management solar plus storage system. And on the right, we also have 9 kilowatts of loads. 4 circuits here, 4 circuits there. The big difference is that when you use a load management system, you're not restricted to any particular set of loads, right? You've got 4 circuits here still, but they're the same circuits. We're now backing up 4 different circuits here. The only restriction, right, is that the loads that run can't exceed the system's backup capacity, which in our case is 9 kilowatts continuous for a single PWRcell M6 battery. As long as the loads don't exceed that 9 kilowatt number, the home circuits will function as normal and the homeowner will not have to change their behavior whatsoever. And this is a major benefit of load management. Your customer gets to operate in their normal way and have access to all of their loads safe with the knowledge that their system can't be overwhelmed by any combination of those loads. This is a higher performance system than a sub-panel setup. So let's take a look at this functionality one more time. What happens when loads do exceed system capacity, right? 9 kilowatts in our example again. For instance, you're running all the essentials and you have the hot water heater going, and then the AC unit decides that it wants to cycle at the same time that all those other loads are running in the home. You can see here we have our circuits divided into 2 categories. We have managed on the bottom, essential up top, and the essential loads are not managed, right? They don't have any load management connected to them. These are the SMMs that are providing the load management for the AC unit and HVAC. We're going to see how these act here in a sec. In this example, basically, when utility power is lost, let's get some utility power in here, right? You can see that the essentials are running. You can see that the hot water heater is running. Imagine that the grid is currently down here. And then let's say that the AC unit wants to start. However, it's got that high LRA, remember? This is going to stress out the system, all right? This is going to stress out the system because now all these loads are trying to run. That big LRA is trying to draw more from the inverter than it has. So what happens is the inverter signals the SMMs to drop loads. So it does that, and then the loads are repowered in order of priority. So basically, the hot water heater is paused, and power is given back to the AC unit first, so we can start up, and quite likely after it gets over that big LRA hump, there will be enough power left over to potentially run both the AC unit and the hot water heater in addition to the essentials. If not, those loads will be paused again. But what's important to note here is that these essential loads are left completely unaffected by the load management that's occurring between these large loads down here. All right. Sure, lower priority circuits, these managed loads here might have to wait, for there to be power available, either for essentials to turn off or higher priority managed loads to turn off. But there is always power available for what you need. That's not going to get taken away by, the hot water heater. It's also worth noting that load management can provide a clean solution to compliance problems. If your HJ enforces NEC 702, then you may have had to have been very strict with the way that you size your sub panel. You may have had to sell more storage than you wanted to cover loads. Well, there's a second part of this code, part B, that basically says that if you have a load management system in use, that the battery only needs to be as big as the maximum load that will be connected or transferred by the load management system. The load management system, remember, prevents the local load from exceeding the battery's capacity. And that means that if you size your unmanaged or essential loads to, meet or be less than the battery's power, and attach the rest of the loads in the home to load management, then you can keep everything in one panel and still meet code. So a very